Today, we are getting into the real nuts and bolts of how AI agents actually get stuff done in the real world. We're going to be talking about agent tools and a really important new standard designed to connect them all called MCP.
So let's kick things off with a pretty simple question. You've got this AI that's so smart it can ace a law exam, it can write amazing poetry. But if you ask it to order you a pizza, it just can't. It hits a wall. So what's going on there?
Well, the answer is actually pretty straightforward. Without a connection to the outside world, even the most powerful AI is basically just a brain in a jar. Sure, it knows all the stuff it was trained on, but it can't check a website, it can't interact with an app, and it definitely can't take any action in the physical world. It's just stuck.
And that gets us to the fundamental challenge for AI agents, right? How do they break out of this digital walled garden? To do anything useful, they have to have a way to connect to everything else. That connection comes from something we call tools. And it's a great name for them. You can think of them as an AI agent's eyes and its hands. They are basically just little programs or functions that let an agent do things. Check the weather, search a company's internal database, or, finally order that pizza by connecting to a delivery service.
But here's the thing. For the longest time, connecting these tools to AI models has been a complete and total mess. Developers have this name for it. They call it the N by M integration problem. And trust me, it's been a huge bottleneck. Here's why it's such a nightmare. For every single new AI model, that's the N, developers had to write custom code to connect it to every single new tool, that's the M. As you can imagine, this just explodes. It's an absolute mess of custom code that's slow, super expensive, and makes building powerful, flexible AI agents a real pain.
So how do you fix a nightmare like that? Well, you stop building custom everything, and you create a universal standard. A single universal key that can unlock any tool for any model.
And that brings us to the Model Context Protocol, or MCP. It's a new open standard that just came out in 2024, and its whole goal is to be that universal interface. So instead of a million different custom connectors, MCP creates one common language that AI apps and tools can use to talk to each other. Simple as that.
The way MCP works is actually beautifully simple. It's got three main parts. First, you've got the host. That's the main AI application you're interacting with. Inside the host is a client, and its only job is to talk to a server. And that server? That's where all the tools and capabilities live. It's just a clean, standard way for things to connect.
And this right here, this is the magic of MCP. It completely decouples the AI agent from the tools themselves. The agent doesn't need to care about the messy, complicated details of how a tool works anymore. It just needs to know how to speak MCP.
And once you decouple those two things, you open the door to a truly plug-and-play future for AI. And that has some absolutely massive advantages.
So what does this plug-and-play future actually look like? Well, first, development gets way faster because you're not reinventing the wheel every time. Second, you get this amazing reusable ecosystem, like an app store, but for AI tools. Third, and this is a real game changer, agents can get what are called dynamic capabilities, which means they can find and start using new tools all on their own, in real time. And all of that leads to way more flexibility in how we build and maintain these systems.
And it's not just about making things easier today. The source material puts it perfectly. MCP helps create these modular, composable systems. It lines up with these really advanced ideas like the agentic AI mesh, which is basically a future where lots of specialized AIs can all work together seamlessly. It's about building for what's next.
Okay, but it's not all sunshine and roses. Anytime you give an AI the keys to the real world, you're also giving it new ways to cause some serious trouble. And MCP, for all its benefits, comes with some hidden security traps we have to talk about. Because this awesome new power, this dynamic plug-and-play connection to the world, well, it also opens up a whole new attack surface, a new landscape of threats that we really need to understand.
So let's look at one of the biggest risks. It's called tool shadowing. Check this out. On the left, we've got a legitimate, safe tool. Notice how its description is super specific. Use this tool only when the user explicitly requests to save a sensitive secret. Now look at the malicious tool on the right. Its description is way more tempting and vague. Use this tool whenever the user mentions save, store, keep, or remember.
Now, you put those two options in front of a well-meaning but kind of naive AI. Which one is it going to pick? It could easily choose the malicious one because the description sounds more useful and covers more ground. And the second it does, poof, your sensitive data just got shipped directly to an attacker. This kind of attack actually has a name. It's a classic in cybersecurity. It's called the confused deputy problem. The idea is you have a program, the deputy, that has a lot of power and permissions, and an attacker who has very few permissions tricks that powerful deputy into doing its dirty work.
Here's exactly how it plays out in the world of MCP. Step 1. An attacker who doesn't have permission to access a secret file tells the AI assistant to go find it and move it. Step 2. The AI, our confused deputy, sees a valid-looking command and just passes it along to the powerful MCP server. Step 3, and this is the crucial failure, the MCP server checks its own permissions, which are high, but it doesn't check the original user's permissions. It just obeys. And the result? The attacker gets the file. Security is completely bypassed.
Okay, so with huge risks like that on the table, how do we actually build agents that are both incredibly powerful and safe to use? Well, as it turns out, the responsibility falls right on the shoulders of the people building them.
And this is maybe the most important thing to remember. MCP is just a protocol. It's a set of rules for communication. It was not built with things like enterprise-level security or identity management or detailed auditing logs baked right in. All of that stuff, that's on the enterprise to build and enforce.
But the good news is there are clear ways to fight back. For every major risk, there's a strategy. To stop random malicious tools from getting injected, you use a strict allow list, a guest list of approved tools. To stop tool shadowing, you make sure no two tools can have confusingly similar names, and you make a human approve risky actions. To stop data leaks, you tag sensitive information. And to fix the big one, the confused deputy, you always check the original user's credentials, not just the server's.
And that really leads us to the final critical point from the source material. MCP is amazing. It provides the standard, that common language for everything to work together. But it's the enterprise, the company building the agent, that has to bear the full responsibility for creating the secure, auditable, and reliable system around it.
So, as we dive headfirst into this incredible new era of connected AI agents, we're left with one really important question. The protocol gives us the connection, making our AIs more powerful than we ever imagined. But the protection? Well, that's on us. And that's definitely something to keep in mind.